Hello everybody, get ready to do Chapter 4, Review and Summary for Pre-Calculus Math today. And today, Chapter 4 Summary, Part 1, Classwork. You have 0 points here, notebook taking, and you will have 90 points here on your classwork sheet, a whopping 90 points, so it's a huge classwork sheet. Email me for those. And teachers and students, today's bell work. Use a calculator to evaluate each one of these functions here on your calculator. And teachers, give your students about 5 minutes. Okay, welcome back for your solutions for today's bell work. Round your answers to 4 decimal places here. Cosine 84, sine 6, cosecant 52, 12 minutes, and then secant 54 degrees 7 minutes. So starting up here, that will give you a 0.1045 radians there for cosine 84. Sine 6 will be 0.1045, and then cosecant 52 degrees 12 minutes will be 1 over the sine 52 degrees 12 minutes. And then that will become 52.2. This is 0.2 is 1/5 of a degree. 12 minutes is 1/5 of a degree. And then that will give you 1.2656 radians. And then secant down here is 1 over cosine. Then 7 minutes is 0.1167 degrees of so that comes out to 1 over cosine 54.1167 degrees is 1.7061 degrees, or rather radians here for your degree calculation. So that is your bell work today. Into our first example here. Use radian and degree measure and convert between degree and radian measure. This is for your 4.1 in chapter 4. So to convert degrees to radians, multiply degrees by pi radians over 180 degrees to convert radians to degrees. So this is to convert degrees to radians. To convert radians to degrees, multiply radians by 180 degrees over pi radians. So we're going to get into this here. Use angle conversion capabilities of a graphing calculator to convert the angle measure, here's our angle measure here, to decimal degree form. Round your answer to 3 decimal places. So we have this situation here, 135 degrees, 16 minutes, 45 seconds. So this becomes 135 plus 16 over 60 plus 45 over 3600 degrees. And then that amounts to 135.279 degrees, 2 decimal degree form. And then this is your 3 digits here. And then down here, same thing, 242, 24 minutes, 9 seconds at 24 over 60. And then 9 over 3600 degrees is 242.403 degrees. Okay, moving on now into our second example here. 4.2, use domain and period to evaluate sine and cosine functions, and use a calculator to evaluate trigonometric functions. So 4.2, because 9 pi over 4 equals 2 pi plus pi over 4, sine 9 pi over 4 would equal sine of 2 pi plus pi over 4. Then sine pi over 4 equals square root of 2 over 2. So knowing that, we can evaluate sine to the negative 17 pi over 6 as sine of negative 17 pi over 6 equals the sine of 7 pi over 6. equals negative 1/2, because we know 17 pi over 6, the negative of 17 pi over 6, the would be equal to the same thing as 7 pi over 6, which equals negative 1/2. And then using its period as an aid. So the period here, 17 pi over 6, would be how many periods? It would be between pi and be between 0 and pi. So negative 17 pi over 6 would be equal to 7 pi over 6, same thing. And then down here, negative 13 pi over 3 would be the same thing as cosine of the negative 13 pi over 3 would be equal to the same thing as cosine 5 pi over 3, which would equal 1 over 2, 1/2 for this one. Okay, moving into 4.3, use trigonometric functions to model and solve real-life problems. So trigonometric functions can be used to find the height of a tree, the angle between a path and a river, and the length of a ramp. Or you could find the slope here of these water jets shooting out. Yeah, you could find that as well. So, architecture, an escalator 152 feet in length rises to a platform and makes a 30-degree angle with the ground. A, draw a right triangle that gives a visual of the problem. Show the known quantities and use a variable to indicate the height of the platform above the ground. That would be your part A, part B, and C are down here, which I want you to do on your own, but I think I'll help you on these. So up here, draw a right triangle. So this would be a good diagram of your issue here. You got a 30-degree angle with the ground, and then your escalator would be 152 feet. So that would be a visual of the problem. And then use the variable to indicate the height. So we basically want to find this over here. So by using a trigonometric function, sine 30 would equal h over 152, opposite over your hypotenuse, and that would be 152 sine 30 degrees. So it'd be 152 times 1/2, be 76 feet here would be your height for that. Going into 4.4, evaluate trigonometric functions of real numbers. So for cosine 7 pi over 3 theta equals 7 pi over 3, which lies in quadrant 1, 7 pi over 3 cosine. And the reference angle is theta prime, would equal 7 pi over 3 minus 2 pi here would equal pi over 3. So, knowing that, cosine 7 pi over 3 be cosine of pi over 3 would equal 1/2. 4 points for this one. Okay, getting into our first guided practice here. Number 7, this would be for 4.4. Evaluate the sine, cosine, and tangent of the angle without using a calculator. So we got these angle amounts here, and we're going to use reference angles here to evaluate each one of these angles. So for this first one, 240, our sine 240 would be the same thing here as negative sine 60 is what it would be on a unit circle. 240 degrees would be the same thing as negative sine 60 degrees, which is the negative of square root 3 over 2, and then the cosine be negative 1/2 for negative cosine 60, and then for tan you would have a negative square root 3 over 2 over the negative of 1/2, which would be 3, square root 3, I'm sorry. And then for 315, again using reference angles here, be the same thing as negative sine 45 degrees, which is the negative of square root of 2 over 2. Again using your unit circle diagram. 315 is the same thing as negative sine 45. And then cosine 315 would be cosine 45. And then tan 315 would be negative tan 45, be negative 1. So that would be the way that you would figure these here. Into our next section here, 4.5, sketch graphs of sine and cosine functions using amplitude and period. So here we have a sketch here of a graph, y equals 3 sine 2x, and then y equals 2 cosine 3x. So again, you can see our amplitude here is only 2, over here it's 3, and then cosine 3x. To do that, we're going to sketch the graph of the function. So we have 1/4 cosine x, and then we have f of x equals 7/2 sine x. So for this one here, for the first one up here, amplitude would be 1/4. So this is what would be what your graph will look like for 1/4 cosine x. And then our period here would be 2 pi. So it'd be this would be 1, and then our the way that you figure your amplitude is 1 over 2 pi is what it would be. So that would be your period of that function there. Down here, well, I'll let you do that. Okay, moving into our next section here. 4.6, sketch the graphs of the tangent and cotangent, secant, and cosecant functions. So here we have a tan function here, y equals tan x. And then over here we have y equals secant x equals 1 over cosine x. So again, if you remember your cosine function, how it goes through this, where it peaks and valleys, this is where your secant function takes off here within these parameters here of the period of your secant function here would be pi, between negative pi over 2 and pi over 2, and then from pi over 2 to 3 pi over 2, etc. So getting into an example here of that, sketch the graph of the function, include 2 full periods. So we have f of x equals negative tan of pi x over 4. So for that situation here, our period would be pi over 4, which would equal 4. So we have a period here of 4, and then 2 consecutive asymptotes, x would equal negative 2 and x equals 2. So negative 2 and over here 2, because we have a period here of 4. And then it's reflected in the x-axis, and then this is what you should have down for your graph for this one here. Negative 2, 2, then 2, and then 6, and then negative 2, and negative 6, and then this would be your see, we're over here, negative 4, 2 consecutive asymptotes, and that would be what that would look like. You have a negative slope here, so your function would tend to have a negative direction in its slope. And then down here, 4 tan pi over x. Our period here would be pi over pi would equal 1. 2 consecutive asymptotes would be negative 1/2 and 1/2. So be negative 1/2 would be here, and then 1/2 would be about here, and then this would be your tan function with this expression here. And for here, 4 is your positive slope here, so it has a pretty steep slope on the positive direction of your slope for this function here. And then we get into 4.7, evaluate the compositions of trigonometric functions. So cosine of arctan phi over 12 equals 12 over 13. So, and then the sine of sine to the negative 1, 0.4, would equal 0.4, because the sine of its inverse would just leave 0.4 for that. Then the cosine again of arctan phi over 12, since we know our tan here is 5 over 12, then our cosine would be 12 over 13. And you can use this triangle here for that, to diagram what these functions are telling us what they are. 4 points here for page 13, classwork. Let's try one now. Write an algebraic expression that is equivalent to the expression. So the secant of arc sine x minus 1. So let y equals arc sine x minus 1. Then sine y would be x minus 1 equals x minus 1 over 1. And secant y would be 1 over negative x squared plus 2x. Then we rationalize our denominator, and then we get this expression here for secant y for that. And then this would be the triangle that would be the reflection of this function here. This is what the measurements would be on your triangle for that. Then we get into 4.8, solve real problems involving harmonic motion. This would be an example here of a function describing harmonic motion. Sine or cosine functions can be used to describe motion of an object that vibrates, oscillates, rotates, or is moved by wave motion. So this would model a harmonic motion kind of a situation. Then we go into this word problem here. A buoy oscillates in a simple harmonic motion as waves go past. The buoy moves a total of 6 feet from its high point to its low point, returning to its high point every 15 seconds. Writing an equation that describes the motion of the buoy where the high point corresponds to the time t equals 0. So with those kinds of parameters there, using a cosine model with amplitude 3, so that would give us an amplitude of 3 here. Your center line would be right here, high point, and then your low point here. Period will be 15 seconds from from our low point to our high point. So high point over to our high point would be 15 seconds, and then d equals 3 cosine 2 pi over 15t will be the function that would model this real life situation. And that is your lesson, classwork lesson for today. If you need homework sheets, solution PowerPoints, or if you have questions, note-taking guides, email me here. Thank you very much.